Good morning, everyone. My name is Sabia from Department of Computer Science Engineering from E section. Today, my topic is particle in a one-dimensional infinite potential. Particle in a one-dimensional infinite potential well. This is the figure of one-dimensional infinite potential well. Consider a particle of mass m moving back and forth between the walls of the one-dimensional box separated by a distance a as shown in the figure. Let the particle travel only the x-axis and is confined between x equals to 0 and x equals to a by two infinitely hard walls so that the particle has no chance to penetrating them. Thus, it does not lose energy when it collides with the walls and its total energy remains constant. This box can be represented by the potential box of width with potential wall of infinite height at x equals to 0 and x equals to a, so that the potential energy V of the particle is infinitely high on both sides of the box, and inside it V is a uniform. Let us assume that V equals to 0 inside the box. V of x equals to 0 for 0 less than x less than a. V of x equals to infinite for x less than or equals to 0 and x greater than or equals to a. Then the wave function psi of x of a particle in the region 0 less than x less than a, where v equals to 0 is described by the Schrodinger's wave equation. This is the equation of Schrodinger's wave equation. D square psi by dx square plus 2m into e minus v by h cut square into psi equals to 0. From particle in a one-dimensional potential well, v equals to 0. D square psi by dx square plus 2m e by h cut square into psi equals to 0. Let 2m e by h cut square equals to k square. D square psi by dx square plus k square psi equals to 0. That is equation 1. The solution for the above equation is given by psi of x equals to a sin kx plus b cos kx. That is equation 2, where a and b are the arbitrary constant. A and b can be determined by the applying boundary conditions. First condition, at a equals to 0, psi of x equals to psi of 0 equals to 0. Second condition, at x equals to a, psi of x equals to psi of a equals to. Applying first condition to the equation 2, we get psi of 0 equals to a sin k of 0 plus b cos k of 0. 0 equals to 0 plus b into 1, that equals to b equals to 0. Substituting b equals to 0 in equation 2, psi of x equals to a sin kx plus 0 cos kx. Psi of x equals to a sin kx, that is equation 3. Applying second condition to the equation 3, we get psi of a equals to a sin ka, that equals to 0 equals to a sin ka. Either a equals to 0 or sin ka equals to 0. b equals to 0, comma, a is not equals to 0. Sin ka equals to 0. Ka equals to plus or minus n pi. K equals to plus or minus n pi by a, that is equation 4. Substituting equation 4 in 3, we get psi of x equals to a sin n pi by a into x. Eigen energy values. We have k square equals to 2me by h cut square. E equals to k square into h cut square by 2m. That is equation 5. We have k equals to n pi by a, where k square equals to n square pi square by a square. We have h cut equals to h by 2 pi, where h cut square equals to h square by 4 pi square. Substituting k square and h cut square values in equation 5, we get E equals to n square pi square by a square into h square by 4 pi square by 2m. En equals to n square h square by 8m a square, where n equals to 1, 2, 3, 4, etc. etc. For n equals to 1, E1 equals to h square by 8m a square is minimum energy of a particle. For n equals to 2, E2 equals to 4h square by 8m a square equals to 4E1. For n equals to 3, E3 equals to 9h square by 8m a square equals to 9E1. This is the figure for energy of eigenvector. This is the level E1 level, E2 level and E3 level. Eigen wave function. We have psi of x equals to a sine n pi by a into x 0 less than x less than a. A is determined by using normalized wave function. Integration 0 to a modulus sine square dx equals to 1. Integration 0 to a square into sine square n pi by a x dx equals to 1. A square integration 0 to a 1 by 2 of 1 minus cos square n pi by a x dx equals to 1, where sine square theta equals to 1 by 2 of 1 minus cos 2 theta. A square by 2 integration 0 to a of 1 minus cos 2 n pi by a x dx equals to 1. By integrating we get a square by 4 of x minus sine 2n pi by a x by 2n pi by a 0 to a equals to 1. By applying the limits 0 to a of both limits in terms, sine term is a 0. A square by 2 of a minus 0 equals to 1. A square by 2 into a equals to 1. A square by 2 equals to 1 by a, where a square equals to 2 by a. A equals to root of 2 by a. Sine n of x equals to root 2 by a sine n pi by a x. 0 less than x less than a. For n equals to 1, psi of x equals to root 2 by a sine n pi by a x. There are two nodes, x equals to 0 and x equals to a. For n equals to 2, psi of 2x equals to root 2 by a sine 2 pi by a x. There are three nodes, x equals to 0, x equals to a by 2, x equals to a. This is the graph for a wave function. We can see the levels E1 level and E2 level energies. Thank you so much.